In this video, I want to show how to do database migrations in managed Kubernetes environments using Flyway as a database migration tool. Flyway is an open source tool that you can use to migrate schema changes in relational databases, and I want to show you how to use it within a managed Kubernetes environment. I have an example project that is called Zero Downtime that you can grab on GitHub. This uses the Quarkus technology and JPA to access a relational database, and it is also deployed to a Kubernetes cluster using, of course, these YAML description files and using what is called an init container. Basically, what we will do, we will package the tool, the FlywayDB tool, in the command line mode into a Docker image, and this image will contain our database migration scripts, and then that will be applied before our actual container starts as a so-called init container in Kubernetes. Init containers run before our actual application, and then the migration will take place before our application will be restarted. And in this case, what we will have a Dockerfile that only comes with the Flyway tool, and we will add some scripts here. And in the baseline version, that's like the first version, we only have one table. So this is our database schema for now with coffee orders, and then we will apply this. How it works is as follows. I have a Kubernetes cluster that for now is empty. And also I have a database service. Where this comes from, in my case, I use a managed Kubernetes cluster using the IBM Cloud IKS managed Kubernetes service. And also I use a database, Postgres, which also comes from the cloud. You can use whatever a database, of course, which is supported. In my case, I use also a cloud database for Postgres, which is a managed Postgres version. So you can check this out. You creating one on the Cloud Console, and then you have a database that actually we can check out as well. So I have a shell to my Postgres database open here, and we will see that actually the schema is empty. So there's no database table yet. What Flyway will do, it will have a table with all the current database schema version information where to apply these scripts to. So in order to make this work, what we will do just for the first time, and this is somewhat like an operations job, is to say, okay, actually we will have a migration like a baseline version. In this case, what it does, it creates a job, or actually a pod in this case, that only runs once. And what it does, it sets the baseline version. So this is a concept of Flyway that you can set a baseline version. In our case, I want to set it to 0 explicitly, because then 1 is already the first version that is stored on the version control. And in this way, what it will do, this job will run, and then we can have a look. It does not do much. It basically just initializes a table, Flyway schema history, with then our baseline schema version 0. We can check this out. So now we have a table actually in our schema. And if I say, well, select from Flyway schema history, then we see, okay, there is one version 0, which is just the baseline here that just initializes this schema or this table for us. Now we can actually do the real deployment. So I can delete this pod again. Not Docker, but Kubernetes to delete pod, because this was just a one-time job. And now I can apply all of my Kubernetes resources that I have in this project. So this applies the deployment YAML that I showed you before, which uses the init container to make the migration to version 1. So this is the Docker image again that contains all of the migration scripts. Right now we only have one, and then afterwards our version of our application will be started. What both containers contain is a reference to a secret which contains the login information to our database. And then what happens now is that our application is now up and running and ready. And also it has, well, two containers because I use Istio as a service mesh. But what we can also have a look at is the containers that are available. And there are 4 containers because we have, well, 2 init containers, and schema migration is one init container. The other one you can ignore, that just comes automatically from Istio. And our schema migration now says, okay, actually we successfully migrated to version 1. If I run this again, then it does not do anything, so that's an idempotent action to check for the versions and see which one has been applied, because now what we will see, there actually is a table. So the table that we just wanted to create for our orders. If we check this out, it actually has the information in here already. And if we then have a look at our Flyway schema history table, now we see that actually the initial schema version 1 has been applied. So this worked already. Now what we can do is that we can access our application. So we can access it using a curl and then of course the IP address of our cluster, and then we can check out the coffee orders here. So this is my example application, which for now is empty. So if I create a new order, which goes as follows, I want to create an espresso and maybe a latte. And then we check this out that now the order's in the system, and of course it also appears in the database, so it will be there in our orders table. Now that is just the baseline version, but actually what I wanted to show you is how to do the migrations with which then are required to do zero downtime deployments. Because basically what happens is that we want to be able to migrate our database version here before the actual application will be updated, will be started. And since we have a rolling update mechanism in Kubernetes, in order to achieve zero downtime, this means that we have to support N-1 compatibility. That means that we have database versions that are compatible with our current application version and the application version +1 or -1, just the next one or the previous one at the same time. Because if we do zero downtime deployments, we will have a short moment when both versions are online at the same time, so they should not collide. In order to do that, I actually prepared some example. If, for example, I want to rename a table or a table column, which will be accessed in my code here. So that is panache with Quarkus, which accesses, in this case, the coffee type. Now, assuming that I want to rename the type to, let's say, coffee type in a database table, so something like, introducing a different column name for coffee type or something like that, then we simply cannot just do this and rename it. Why? Because if I rename it on the database table in the migration script already, then there's a short moment where the old application cannot access the database column anymore because the column has changed. So in order to do that, I actually cannot just simply rename it, but what we have to do, and this is a bigger topic of doing database migrations, we have to migrate in steps. So for that reason, if I apply a new version that I prepared here, what we have to do is similar as follows, that we say, okay, actually we have to do something like a temporary column where we introduce this, what will be saved in a database. So we basically say, okay, just add a temporary column, which would be the end result name, coffee type. And now change this, that we also, save the information in this column. And I can just do this with that helper method to say, oh, please always execute this once you update in the database, to set the temp value to this one as well, to just the same value that afterwards we can migrate to the new one. But we have to have both in place at the same time. So then what happens is, let me just update the new version to go for deployment coffee shop, because how we now perform this deployment with Flyway is as follows, that we just build new Docker images and update the images here to say I have a new application version. And of course, I also have a new database migration version using this migration script. What I also do, I remove some constraints. So it drops the not null constraint, because while I'm doing this migration, while in the step of multiple deployments to migrate my database, I sometimes have to get rid of some constraints temporarily because I have to move things around. And in this case, what it does then, once this has been applied, now I can look at the logs of my init container as well for the schema migration. Now it says, okay, great. Version 1 is already there, but version 2 is new. So I migrated the schema using version 2. And now if I have a look at my table, I see that there is a new column, and also the not null constraint disappeared from my type column before. Then what I do in the next step, I can actually still look at my application, of course. So that is still working because I want to achieve zero downtime deployments. And now let's have a look at the next step. Now what I do then next is basically, well, I make sure I switch the columns what I write to and what I read from. So in this case, I already, well, you saw I switched the annotations. I'm already reading from the new value, because then I say, okay, just update the table that you store. You set the type to all the new values already. So this is because of the short moment when an old application only wrote to the old column. But then now in the meantime, the temporary version writes to both. And then I say, okay, then in this case, once that has been applied, you can already set a new constraint, because then it will always be set. And also switch the values that you then already read from the new table. In order to do that, let's deploy the new version, which also updated again the images for my application image and the schema migration image. And once this is the case, we can have a look at the pod that then will be started. And of course, we can have a look at the migration container. So the init container that then migrates it to version 3. Orders, so now the constraint has been set. And also I expect that my orders are still there, and then it works. And also I can create a new coffee that should still work, because my application is always up and running. Now let's go to the next step. And again, what I'm showing you is just an example here, where in this case, I already remove now the code occurrences of the old table, because this is then not required anymore. Deployment coffee shop. So here I just updated the version of my application again. And then afterwards, what I will do, I will get also one version, migration 5. And this is then the final version, where I actually remove the old column because it's not required anymore, and all of the data has been transferred to the new column before. And if I then apply this as well, let's wait for the rollout here. If I apply then this new version, then we will see that also it has the latest database schema version. Once this has been applied, you can check the logs again of the schema migration init container, and then this is the final version 4, which still has the 2 tables, and this, not dt, but \d orders. This is now the table here of our orders, where we already have the new coffee type column, which is in this case not nullable. And of course, again, if we look into the orders that we have in the system, so this of course still works because we had the deployment with zero downtime. So this is how you can use Flyway as the migration tool for relational databases. And by using the init container capabilities of Kubernetes, we make sure that these changes will be applied before every application rollout, before every rollout of a new version. These changes are idempotent. Versions that already have been migrated won't be done again, because the information is stored in a database. I hope that was helpful. Thanks a lot for watching.